Hello. Today I'm going to create a battery. More specifically, I'm going to create the very first battery ever made. This was first created back in the 1800s using copper, zinc, and an electrolyte. Today I'll be using essentially the same thing. For the copper, I will be using quarters, since they are 92% copper. And for the zinc, I'll be using pennies, since they're 97% zinc. For the electrolyte, they used a piece of cloth soaked in a brine, which is water and salt. And I'll be using essentially the same thing, except I'll be using paper towels instead of a cloth. So I'm going to build it here. This battery is called the Voltaic Pile, and it was a pretty big leap in terms of electricity, because it was the first thing invented that could deliver a steady current. Before, they could generate a charge on a substance and they could have it shoot off instantaneously, sort of like a static shock that you get from rubbing your feet on the carpet and then touching a doorknob. So this was a pretty big discovery. So now that it's built, I'm going to test the voltage of it to see how powerful this battery is. It is not very powerful at all. You won't be able to see this, but I'm using an analog multimeter and it's reading about 1 volt. So pretty minimal. That's less than a AA battery. The guy who created this encountered the same problem as well. He ended up using zinc and silver instead of zinc and copper. Unfortunately, I don't have silver, so I'll be substituting aluminum, which I picked up at Menards the other day. And I think it'll work a lot better, so I'm going to build that. So I'll just deconstruct what I have here, and I'll keep the pennies since they're the zinc, and I'll just replace all the quarters with these little aluminum washers I have here. Now that our new battery consisting of zinc and aluminum is complete, let's test out the voltage on this. We're getting, this time, close to 2 volts, I'd say about 1 3/4, which is pretty good, a pretty good improvement over what we had, where we were barely getting 1 volt. Since we know the voltage in this battery I've just created, but we need to know what the current is to figure out the power that it can deliver. What we can do is figure out the resistance of it, and using the relationship between voltage, current, and resistance, we can calculate the current within it. So I'll just calculate the resistance here quickly, and it's coming out to be 20 ohms, which is a considerable amount, but that makes sense because it's not a very good battery. So then we can say that voltage is equal to current times resistance, and the voltage is about 1.75 volts and the resistance is 20 ohms. And so we can divide that over, and that will come out to be 0.0875 amps, which is not very much. That equates to 87.5 milliamps. So let's do some calculations using this. So since I know the current and the voltage of the battery I've created, I can figure out what the power is using the equation that power is equal to current times voltage, and you can see that comes out to be 0.15-ish watts, which is not very much. Then I went ahead and I did some research about my phone, the iPhone 5, and I thought it would be interesting to see what would happen if I tried to charge this using strictly my battery for an entire year. And I found out that the iPhone 5 consumes about 3.5 kilowatt hours annually. My battery can provide the 0.15-ish watts for about an hour before it dies. And so if we divide those two figures out, we know how many batteries I would need to charge my iPhone for a year. That comes out to be 22,857 batteries. And then I thought it would be interesting to see how many coins that would be. And so I did that calculation, and that came out to be 571,000 quarters alone. And then if I replace the aluminum washers with pennies, that would also be 571,000. And so in total it would be more than 1 million coins to produce enough batteries to charge my iPhone for a year. And then I was curious as to how much money this would cost. And so I did that calculation, and that came out to be a little less than 150,000, which is a staggering number. It's massive. And then I was like, well, how much would it cost if I just used the electric company's electricity? And that is a minuscule 41 cents a year using the electricity that comes out of my outlet. And so I think that says a lot about how far electricity has come since the 1800s and how inefficient this battery is that I've created. That's all I have to say. Have a good night.